In this video, I will be demonstrating the process of calibrating the Cypher in preparation for imaging or force data acquisition. So start the software by following the same procedures described in the MFP3D video. Remember, all the tutorials in these series are for AC mode. Then put on the camera by clicking the camera icon here. Turn on the illumination by moving the slider here to the right. You do not have to move the slider full range, as you can see, to get good illumination. The slider here is used for zooming the video. Click on the spot on button here in the center of the tip to place the laser there. This also helps in bringing the tip into view. As you can see, the cantilever is quite blurry, so I will try to focus on the cantilever, which is the same as finding the cantilever. I do that by going to the Engage panel here under the Approach tab. Ensure that Move Focus is activated and use these arrows to adjust the focus until the end of the cantilever closest to the tip is in focus. The whole cantilever cannot be in focus at the same time because it is at 11 degrees angle. If you find the single arrows too slow, use the double arrows, they are faster. Click on the Set button beside the Focus on Tip button to let the system record the new tip position. Next thing to do is to tell the optical microscope the relative position of the tip to the surface. You do this by finding the surface. Use the arrow here to do that. So intuitively it should be down, so I click on the down arrow repeatedly until you find the surface. The clear white circle with sharp edges implies you have found the surface. Then click the single up arrow 3 times. This is important so as to avoid crashing the tip. Click on the Set beside the Focus on the sample to record the relative position of the sample. Verify that the tip is still in focus by clicking on the Focus on Tip. This will move to the last recorded tip position. You can do the same for the sample by clicking on the Focusing on the Sample button. Then now click on the Move to Pre-Engage button. Use the arrows located here to maximize the sum, which around 8 here. Remember, I explained the benefit of maximizing the sum in an earlier video. Next thing is to find the resonance frequency. For this tip, which is AC 240 standard, I know it is about 53 nanometers per volts. This value will be different from the AC 160, which is about 40 nanometers per volts. I will show you how to calibrate this parameter in a later episode. Zero the photodiode by clicking on the 0 PD button. You can click as many times. Then I set the amplitude to about 100 mV, then I adjust the set point to about 80%. Then adjust the phase to 90 degrees in the Tune tab if necessary. Then I click on the Start Tip Approach on the Engage panel. This process should move the tip closer to the sample until the set point is reached. The Z-meter here hints you on the process. When the process is complete, the computer will beep, and the tip will be left about half the scanner Z range, about 3 microns, off the sample surface. You see a notification here at the Agora command window displaying the value of the Z signal when that happens. So it means that when I engage, the Z signal should be about this value. I will try that by pressing the Engage button here. It should stop here, but it did not. This is false engagement. In most cases, you might not encounter this issue. If you do, stop the process by pressing the Stop button located main tab of the master panel. Decrease the point a bit and engage again. It is not engaging, so what I will do is to try the trip approach with a smaller point. Note the voltage. The Z piezo stopped in this case. Now we see that the piezo stopped at almost the similar voltage shown in the Agora command window. Now you can start imaging your samples. You can go ahead and find the critical amplitude which will give you control of the regime you want to image your samples. Next topic we will be looking at how to perform the second calibration in preparation for force data acquisition.